Hi everyone, myself as Lakshmanachari, working as Assistant Professor in the Department of EC, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss the subject analog and pulse circuits. So the topic is introduction and classification of amplifiers. So the topics we are going to discuss are introduction to the amplifiers, necessity of amplifier, and classification of amplifiers. So before going to the topic, first we will discuss what is amplifier. Amplifier is an electronic circuit or device which increases the strength of a weak signal without distorting its wave shape. So amplifier it is an electronic circuit or device which will increases. So increases or boosts a weak signal without distorting its shape. Suppose if you have an input signal like this one. So this is an input signal. So this we are amplifying, that means boosting the signal using the amplifier. So after boosting, the output will be increases the amplitude level. So without changing its shape. So the shape should be reproduced without any distortion. So that is called amplifier. So whatever the device it will do the amplification, that is called the amplifier. And the amplifier will do the function of amplification. So amplification means the function of magnifying the amplitude of the given input signal without distorting or without altering. So without altering its other properties is known as amplification. So other properties like frequency and phase. So amplification is the process of magnifying the given input signal without changing its other properties like frequency and phase. So that is called the amplification. And there are in many situations wherein the signal pick up from the source is very feeble to be of any use. It has to be magnified before it can be applied or drive to any output device like some speaker, motor, so like that. So before we apply to the loudspeaker, it should be amplified. And in electronics, the small signal amplifiers are commonly used device as they have the ability to amplify a small weak signals. So that is a amplifier. And see a diagram of amplifier. So generally the amplifier it can be considered as a two-port network. It has two ports. One is input port and another one is the output port. Okay. So the amplifier, so it has two ports, input port and output port. So the input voltage it will be represented with V in, and input current it will be I in, and output voltage V out, and output current I out. Okay, so this is a amplifier, and the gain of the amplifier it can be represented with capital A. So what is gain? So gain is a ratio of output by input. So output voltage by input voltage. So that is a voltage gain. So generally the amplification. So the amplification can be categorized into three different types. The first one is the voltage gain. So the voltage gain. So amplification it can be measured in different parameters. So voltage gain, current gain, and power gain. So here the amplifier it will amplifies the given input signal. So consider a small input signal. So like this. So this is a small input signal. So the small input signal it will be amplified, and the amplified version of the given input signal we are getting at the output side of the amplifier. So finally you will get the amplified version of the output signal like this. So this is a amplified version of this one. So this is a amplified version of the given input signal. And the different types of gains are there. So the first one is the voltage gain. So voltage gain. So in general, the voltage gain, it will be represented with a capital A. Capital A. And voltage gain, it will be represented with A suffix V. And it is a ratio of output voltage to the input voltage. So that is called voltage gain. Similarly, the next one is the power gain. So power gain is a ratio. Next one is a current gain. So current gain is a ratio of output current to the input current. It will be represented with A suffix I. And third one is a power gain. And power gain is a ratio of the output power to the input power. So it will be represented with A suffix P. And the power gain, we can also represent the product of the voltage gain and the current gain. So the product of voltage gain and current gain, it can be considered as a power gain. So this is a amplifier. And here the gain, so the gain means the ratio of output to the input. Suppose if the input is having a 1 volt, so input applied with a magnitude of 1 volt, and the output amplified output, it gives suppose 50 volts. So 1 volt up input and 50 volts is the output. So what is the gain of this amplifier? So this is a voltage gain. So a voltage gain, it will be represented with A suffix V. So that is equal to output voltage by input voltage. So what is output voltage here? The output voltage is 50 volts by what is input voltage? Input voltage is 1 volt. So that is equal to 50. And here the gain, so the gain, it doesn't have any units, so unitless dimension. So this is a voltage gain. So voltage gain is equal to 50. So that means the input is amplified by 50 times. Okay, so that is a amplifier. And coming to the amplifier, so as we know, the Bjt acts as an amplifier. And we have two types of transistors here. So one is NPN bipolar junction transistor, and another one is a PNP bipolar junction transistor. So based on the current direction, so the transistors are classified into two types. One is a PNP and another one is a NPN. So if the current direction is out, then that is a NPN transistor, and if the current direction is inside, then that is a PNP transistor. So can a Bjt acts as an amplifier if we apply input signal to the amplifier inputs directly. So can the Bjt acts as an amplifier if we provide the input directly to the input terminals of the Bjt. So suppose if you have a transistor like this. So this is a common emitter amplifier. So emitter, base, collector. So if you apply a input signal directly to the input terminals of the transistor or Bjt, it cannot amplify. It cannot amplify. So to amplify the given input signal, the transistor should be operated in the active region. So to operate the transistor in the active region, it requires biasing. It requires biasing. So we will see what is biasing. Biasing is the process of operating the device in a desired region or any one of the region. So we have three regions. So that are active region, cutoff region, and saturation region. So this Bjt should operate in one of the regions so that it will be in the active region. So if the Bjt is operated in the active region, then only it can be acts as a amplifier. Next, coming to the necessity of an amplifier. So nowadays we are using the amplifiers in mostly in our home appliances also we are using this amplifier. Okay, so if you see the block diagram of the PA system, so this is a PA system. It consists of different components like microphone, voltage amplifier. So two voltage amplifiers we are using here, and the last stage is the power amplifier, and finally we are using a loudspeaker. So these are the main modules or components using in the public address system. So PA system means public address system. So here, if you come to the operation, so initially we are using a microphone. So microphone, it converts the voice signals into the electrical signals. Voice signals into the electrical signals. So after that, the electrical signals we are applying to a voltage amplifier. So voltage amplifier, and here, so initial stages are voltage amplifiers because the signal received from the microphone or any sensor, it will be very small in voltage, like some millivolts, microvolts range. So that should be amplified before it can drive to the output device like some loudspeaker or motor. Okay, so that's why the initial stages are voltage amplifier. So initially we need to increase the voltage level. So after that we are increasing the current level, and finally we are driving that output signal to the output device like loudspeaker. So here the output device loudspeaker, it converts the electrical signals into the voice signals. Electrical signals into voice signal. So here the main function of the voltage amplifier is to increase the voltage level. To increase voltage level. So the initial two stages. So these two stages are used to increase the voltage level, and after that we are increasing the current level. So the current level I we are increasing by using the power amplifier. So voltage amplifiers are considered as a small signal amplifiers, and power amplifier is considered as a large signal amplifier. So PA system is anything that amplifies sound, so more people can hear it. So this type of PA systems were using in the large public gatherings or meetings, etc. And also here you can see a physical structure of the PA system. So here it contains some microphone. So this is a microphone. So this microphone, it converts voice signals into electrical signals, and here this is a amplifier come loudspeaker. So inside that there is an amplifier and a loudspeaker. So that electrical signals are boosted. Initially voltage levels are increased, and after that current level is increased, and finally that output signal we are driving to the output device like a loudspeaker. So that loudspeaker, it converts the electrical signals into the voice signal. So finally the original signal we are reproducing at the output of the loudspeaker. So that is a PA system. And here need for cascading. So just before we have seen the block diagram of the PA system, public address system. So in that PA system we have seen more than one stage. So that means we have seen three stages. So first two stages are voltage amplifiers, and third stage is the power amplifier. So power amplifier. So total three stages. So what is the need of cascading these amplifiers? So amplifier should have a desired voltage gain, current gain, input resistance, output resistance, like that. So with a single amplifier we cannot achieve a desired voltage and current gains. So that's why two or more amplifiers we are connecting in a cascaded manner. So cascaded manner means connecting the output of one stage to the input of the second stage. And similarly, the output of second stage we are giving to the input of the third stage. And finally, we are taking the output from the third stage. So in this way, many amplifier stages are connecting in a cascaded manner. So with a multi-stage amplifier, we can achieve desired voltage gain and current gains. So this is a necessity of or need of the cascading. And also one more advantage is hence more than one amplifier circuits are cascaded such that input and output provides impedance matching. Input and output provides impedance matching. That means suppose if you have to transfer a maximum power, the output impedance of the source should match with the input impedance of the amplifier. Similarly, the output impedance of the amplifier should match with the input impedance of the output device, so that we can transfer maximum power. So that is a cascading. And here you can see the cascading of a two-stage amplifier. So here you can see the two stages. This is stage 1 and this is a stage 2. So we have applied a input signal Vs, and the Rs is a source resistance. So every source, it is having some internal resistance. So that internal resistance we are representing with Rs. So we are connecting to the input is applying to the stage 1, and output of stage 1 we are giving to the input of the stage 2. So this is a input of the second stage. And finally, we are taking the output across the second stage. So this is in this way we can connect any number of stages. So these stages are connected such that output of first stage is connected to the input of second stage. So here, see how to calculate the overall gain. So the gain is equal to the output by input. So here we are finding the voltage gain. So voltage gain is the ratio of output voltage to the input voltage. So the overall voltage gain is equal to the overall output voltage. So that is equal to V02 by overall input. So overall input is V in 1. So this is V in 1. So that is equal to, if you write separately stage wise, so when we are calculating overall voltage gain, we need to consider the last stage first, and after that next stage, previous stage. So like that. So always we start with the last stage. So last stage is the second stage. So the second stage voltage gain is the ratio of V02 by V in 2. So because the output voltage V02 by input voltage V in 2. So this is a V02 by V in 2. Similarly, the voltage gain of the first stage will be V01 by V in 1. So V01 by V in 1. Okay, so this is it. So here V01 is equal to V in 2. V01 is equal to V in 1. Because here the output voltage of the stage 1 we are giving to the input of the second stage. So here V01 is equal to V in 2. Because the same voltage only we are applying to the input of the second stage. So finally AV, the voltage gain, overall voltage gain, it can be equal to the AV2. So AV2 means it is a voltage gain of the second stage multiplied with the voltage gain of the first stage. So this is a overall voltage gain. So in this way we can calculate the overall voltage gain for a multi-stage amplifier. Hence the voltage gain of multi-stage amplifier is the product of the voltage gains of the individual stages. So in this way we are calculating the overall voltage gain of a multi-stage amplifier. Okay, so these are the different stages we have discussed in the PA system. So in PA system we have 4 stages. The first stage is a microphone. So microphone, it converts our voice signals into the electrical signal. And second stage is a preamplifier. So preamplifier, these are called the small signal amplifiers, nothing but voltage amplifiers. So they will increase the voltage level of a small signal, because generally the signal received from this microphone will be in the order of millivolts or microvolts. So that is very, very small signal. So that is not sufficient to drive the output device like loudspeaker. So that's why by using the voltage amplifiers or preamplifiers, we can increases the voltage level of the given input signal. So after increasing the voltage level, then we are applying to the power amplifier. So power amplifier, they will increases the current level. They will increase the current level, and finally the output signal we are giving to the loudspeaker. So after increasing the power level of the given input signal, then we are applying to the loudspeaker. So loudspeaker, it converts the electrical signals into the voice signal. So in this way, finally we are retrieving the original audio signal. And coming to the topic classification of amplifiers. So in general, the amplifiers we are classifying into different types based on some criteria. The first criteria is based on the frequency range. So the amplifiers we have classified based on the frequency range into different types. That are, the first one is the audio frequency. First one is audio frequency. So the range of audio frequency is from 20 Hz to 20 kHz. So the amplifiers used in that audio frequency range that are called audio frequency amplifiers. And coming to the second one, RF, radio frequency. So the range of frequencies will be greater than 20 kHz. And third one, video frequency. So video frequency will be 5 kHz to 8 kHz. And very low frequency. So 10 kHz to 30 kHz. Next, low frequency. 30 kHz to 300 kHz. Next, medium frequency. 300 kHz to 3 MHz. High frequency. 3 MHz to 30 MHz. Next, ultra high frequency. That are 300 MHz to 300 MHz. And next, ultra high frequency. So ultra high frequency range is 300 MHz to 3 GHz. Next, finally, super high frequency. Super high frequency is more than 3 GHz to 30 GHz. So these are the classification of amplifiers based on the frequency range. So the amplifiers are classified into different classification. So based on the frequency range. So audio frequency, radio frequency, video frequency, VLF, very low frequency, medium frequency, high frequency, ultra high frequency, super high frequency. So these are the classification based on the frequency range. Next one, classification of amplifiers based on the variation of input base current. Variation of input base current with respect to its DC value. That is nothing but IBQ. So based on this variation of input base current, so amplifiers are classified into two types. One is small signal amplifiers, and another one is large signal amplifiers. So we will see the first one, small signal amplifiers. So when this is a single stage common emitter amplifier, and when a AC signal is applied, then the values IB, IC, VCE starts varying from their DC values. So if you see the block diagram, we are applying some AC signal. So this AC signal, it is having some DC value also. So this DC value, it will be blocked by the capacitor, input capacitor C. So because of blocking that DC, so its DC base current will be stabilizes. So because of blocking the DC, the operating point of the transistor stabilizes. The operating point of the transistor stabilizes. So when you apply this AC signal, then it starts varying of the input base current with respect to its DC value, IBQ. So see here. So if you see the base current, so base current here. So this is IBQ is the it's a DC value. So we are applying a AC signal. So this is a AC signal. When we apply a AC signal, the AC signal, it starts varying its the base current starts varying according to its DC value IBQ. Okay, so the base current is in the order of microampere. And next one is a collector current. Collector current. So because the IC is equal to beta IB. So because of this IC and IB both are directly proportional. So that's why the IC and IB both are in the same shape. Okay, and but the difference is the IB is in the microamperes and IC is in the milliamperes. So because the IC is equal to beta times the IB. So that's why the IC collector current will be in the milliamperes. And the voltage VC. The voltage VC. So VC is a collector to emitter voltage. Collector to emitter voltage. So here the output waveform, it will be in 180 degrees out of phase, because this is a single stage CE amplifier. So in single stage CE amplifier, there is a 180 degrees phase shift with respect to the input signal. And also the output voltage is somewhat less, because the output voltage VC, so if the collector current, if the base current increases, so base current increases, then the collector current also increases. So if the collector current increases, the drop across the load resistor increases. So the drop across the load resistor increases, then the voltage across this collector and emitter will decreases. So that's why you will get a less collector to emitter voltage. And here, so the variation of this base current with respect to its DC value, the amplifiers are classified into two types. One is small signal amplifiers and another one is large signal amplifiers. So in small signal amplifiers, the variation of AC signal with respect to its DC value is small. Let's assume, so the IBQ will be 10 microamperes. So 10 microamperes. And the maximum value of the AC signal, let's assume 1 microampere. And minimum value, it will be 1 microampere. Minimum will be -1 and maximum will be +1. So what is the variation? So here the variation will be, so variation is this one. So 10 microamperes minus 1 microampere. Okay. 10 minus 1 microampere. So 9 microampere. Okay. So 9 microampere. So this 9 microampere, it is comparable with its DC value. So DC value is 10 microampere. So 10 microampere is comparable with the 9 microamperes. So here the variation. So the variation will be very high. Variation will be very high. So that's why these are called large signal amplifiers. Large signal amplifiers. So variation will be more here. And second one is a small signal amplifiers. So see here. So let's consider the maximum AC signal is plus 9 microampere and minimum will be minus 9 microampere. So in small signal amplifiers, so the variation will be 10 microamperes minus the maximum positive voltage is 9 microampere. Okay, so 10 microampere minus 9 microampere. So 1 microampere. So that means this variation 1 microampere, it is very small when you compare with the its DC value IBQ. So IBQ value is 10 microampere. IBQ value 10 microampere. So that's why the variation of the AC signal with respect to its DC value is small in small signal amplifiers, and the variation of AC signal with respect to its DC value large in the large signal amplifiers. So the variation in the large signal amplifiers here is 9 microampere, and the variation of variation will be small in the small signal amplifier. So these are the small signal amplifiers and large signal amplifiers. And next one is amplifiers, classification of amplifiers based on the coupling. So based on the coupling, so the amplifiers are classified into three types. One is RC coupled amplifier, and the second one is a transformer coupled amplifier, and the third one direct coupled amplifier. So first one is a RC coupled amplifier. So here you can see the block diagram. Here you can see the circuit diagram. So here this is a two-stage RC coupled amplifier. It is a first stage and it is a second stage. So it is a two-stage RC coupled amplifier. So we are applying a input signal by using some signal source. So that we are applying to the base of the first transistor. We are applying to the base of the first transistor, and we are getting the amplified version of the given input signal at the collector of the first stage, and the output of first stage we are giving to the input of the second stage, and again the same input signal, it will be amplified by the second stage, and finally the amplified version of the given input signal we are getting at the output of the second stage. Okay, so in this way we are getting the amplified version of the given input signal. But here in this RC coupled amplifier, we are using the resistor and coupling capacitor as a coupling elements. So resistor R and capacitor C. So R and C. So we are using the resistor and capacitor as a coupling elements here. So that's why it is called RC coupled amplifier. And the second one is the transformer coupled amplifier. So in transformer coupled amplifier, instead of the elements resistor and capacitor, we are using a transformer. So here we are using two types of transformers. One is a coupling transformer and second one is a output transformer. So the coupling transformer, it couples the output version of the given input signal from the first stage to the input of the second stage through the coupling transformer. And finally we are getting the output version of the given input signal at the second stage output. So here. So the main difference between the RC coupled amplifier and transformer coupled amplifier is so instead of resistor and capacitor, we are using a transformer. And third one, direct coupled amplifier. So in direct coupled amplifier, we are not going to use any type of coupling elements. So in the first category, we have used resistor and capacitor. In the second category, we have used transformer. But in this third method, we are not going to use any such coupling elements. So that means the output of first stage, we are giving directly to the input of the second stage. So that means we are not using any coupling elements. So directly the output of the first stage we are giving to the input of the second stage. So that's why it is called direct coupled amplifier. So these are the classification of amplifiers based on the coupling. And next one, classification of amplifiers based on the parameter that is amplified at the output. So based on the based on the quantity to be amplified at the output, the amplifiers are classified into three types. One is voltage amplifiers, and second one is current amplifiers, and third one is power amplifiers. So in voltage amplifier, the quantity to be measured is voltage, and similarly in current amplifier, the quantity to be measured is current I, and in the power amplifiers, it is power. So these are the amplifier classification based on the one parameter. And next one, based on the mode of operation and conduction angle. So based on the operation and conduction angle. So based on the conduction angle, so the amplifiers are classified into different types, that are class A, class B, class AB, and class C. Okay. So these are amplifiers classified into different types, that are class A, class B, class AB, class C. So how they classified? So based on the operation and conduction angle. So conduction angle. So this is a DC load line. So this is on the x-axis VCE we are taking. In the y-axis it is IC. So it is a DC load line. Okay. So if the operating point is located on the center, such type of amplifiers are called class A power amplifiers. And if the operating point is located exactly on the x-axis, then that is called class B power amplifier. If the operating point is located anywhere from this point to this point, that is called class AB. So that means for class AB power amplifier, the operating point, it could be anywhere from this area to this. So it could be here or it could be here, so like that. But it should be from x-axis to the center, anywhere it could be. And coming to the class C power amplifier. So for class C power amplifier, the operating point is located below the x-axis. So that means below x-axis means it could be here or here, so like that, below the x-axis. Okay. So based on the operating point, the power amplifiers are classified into different types, that are class A, class B, class AB, and class C power amplifiers. And see the output waveforms. So we have seen different types of power amplifier. So their output waveforms here. So if you see the class A power amplifier. So class A power amplifier, the output waveform will be like this. So in class A power amplifier, the conduction angle is 360 degrees. That means the output load current flows for entire given input signal. So that is for class A power amplifier. And class B. So in class B power amplifier, the conduction angle is 180 degrees. So the conduction angle is 180 degrees. So 180 degrees means only half cycle. So in class B power amplifier, the output current flows only for 180 degrees of the given input signal. Okay. And coming to the class AB. So for class AB, the conduction angle will be 180 degrees to 360 degrees. 180 to 360. Okay. So the output waveform will be like this. And the last one is a class C. So for class C power amplifier, the conduction angle is less than 180 degrees. So that means the output current flows only less than 180 degrees of the given input signal. Okay. So the output current flows like this. The output waveform. Okay. So this is a classification based on the operating point. And there is a comparison here. So we are comparing all the power amplifiers, class A, class B, class C, class AB. So conduction angle. So for class A, 180 degrees, 360 degrees, and class B, 180 degrees, and for class C, it is less than 90. Class C, it is less than 90, and for class AB, it will be 180 to 360. And position of Q point. So for class A, it will for class A, center point on the load line, and for class B, it is on the x-axis, and for class C, below x-axis, and for class AB, between the x-axis and the center load line. Okay, and overall efficiency. So the class A, it is having a poor efficiency, that is from 25 to 30%, and for class B, it will be 70% to 80%, and for class C, it will be higher efficiency because it conducts for very less time, so that efficiency will be more here. So the higher efficiency 80%, and coming to the class AB, the efficiency will be 50 to 70%. And signal distortion. So the amplifiers, this is a comparison of we are comparing with respect to these parameters. So conduction angle, position of Q point, overall efficiency, signal distortion. So the signal distortion, it will be none if correctly biased. So if you provide a correct proper biasing to the power amplifier, class A power amplifier, then there is no distortion in that amplifier. And for class B, there is a distortion that is called crossover distortion on the x-axis. And for class C, the distortion will be more. And for class AB, there is a small amount of distortion. So this is a comparison of the different power amplifiers. And the last one is in terms of tuning. So in terms of tuning, the amplifiers are classified into the single-tuned amplifiers and double-tuned amplifiers. So you can see the block diagram, circuit diagram of the single-tuned amplifier here. So it seems it is similar to the single-stage CG amplifier, but the difference is so in a single-stage CG amplifier, the load resistor RL, it will be RL or RC, it can be replaced with a tuned circuit. This is a tuned circuit. So tuned circuit is nothing but it is a parallel combination of the inductor and capacitor. So generally, this type of amplifiers are used to select a particular frequency. It is used to select a particular frequency, tuning. So generally, it is used in the to select a particular frequency in the FM, frequency modulation. So you will listen to songs from using the FM, frequency modulation. So in FM, different types of channels are there. 98.5, 98, 98.3, 99, 101, 100. So we need to select a particular frequency. So then by using this tuned amplifiers, we can select a particular frequency. Okay. So by varying this capacitor C, then it will select a particular frequency. It is a single tuned amplifier. And coming to the double tuned amplifier. So in double tuned amplifier, it is cascading of the two single tuned amplifier. Okay, so it is just a double tuned amplifier. So in this class, we have discussed the basics of the amplifiers. After that, we have discussed the necessity. So why we are using an amplifier, and finally we have discussed the classification of amplifiers based on different criteria. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.